Welcome to True Projects. In this video, we are going to explain about the project that is design of an iterative method leveraging deep Q networks for intrusion detection system operations. So before getting into the execution first, let us understand what is this project about. So cyber attacks, they are becoming increasingly sophisticated, making it harder to protect modern network systems. Network intrusion detection systems that are NIDS play a crucial role in defending networks by monitoring traffic and spotting malicious activities before they can cause harm. So these systems are essential for maintaining the security and integrity of the sensitive data in organizations. However, traditional NIDS, that is, NIDS approaches have significant limitations. Signature based systems rely on known attack patterns, so they often fail to detect new or slightly modified attacks. And anomaly based systems, on the other hand, try to identify unusual behavior but frequently generate false alarms by mistakenly flagging in normal network activity as malicious. So, this makes it clear that conventional methods are either too rigid or too sensitive to effectively handle today's dynamic cyber threats. So, traditional intrusion detection systems. So, traditional intrusion detection methods, they also struggle because they can't easily adapt to new and changing attack strategies. As cyber threats evolve, these systems often fall behind and fail to recognize emerging attacks. Moreover, conventional approaches they require a lot of computing power, which makes it difficult to use them in real time. High traffic networks. This combination of low adaptability and high resource demand shows that there is a strong need for smarter, more flexible and efficient intrusion detection systems that can keep up with constantly changing cybersecurity threats. So to overcome with all such issues, this project has designed a hybrid network intrusion detection system, which means it combines multiple techniques to improve performance. So here it uses deep reinforcement learning, that is DRL algorithms, which are capable of learning and adapting to changing cyber threats over time. So here in this project, five different DRL algorithms are used, which are DQN, DDPG, PPO, TD3, and SAC. They are implemented separately. Each algorithm is tested individually to see how well it can detect intrusions and can handle the constantly evolving nature of attacks on network. So here, each deep reinforcement learning algorithms in the system has a specific role in detecting network intrusions. So coming to DQN, it is responsible for simple yes or no decisions such as whether to block or allow network traffic. Then we have DDPG. So this DDPG, it handles more complex situations, allowing the system to respond to attacks that require nuanced options. And coming to PPO, it ensures that learning process remains stable and efficient, which is important when dealing with constantly changing network conditions. Coming to TD3 and SCA, so TD3 it helps the system decisions more reliable by reducing errors and evaluating possible actions. And SAC it allows the system to explore and adapt, making it capable of identifying new or unexpected threats. And in addition, as the proposed approach, that is as a fusion approach, here we are combining DQN, TD3, and naive base. This combination takes advantage of the learning and adaptability of reinforcement learning while also using the simplicity and statistical power of traditional machine learning method. And the result is well balanced system that can make smart decisions while efficiently classifying network activity. And here to check how well the system works, several standard evaluation metrics are used. So here we have used accuracy, which sees how often the system is correct, and coming to FPR, that is false positive rate, it is how often normal activity is wrongly flagged as an attack. Then we have detection rate. So this detection rate is how well it catches the actual attacks. Then we have F1 score. F1 score is which balances the precision and recall using the metrics, ensuring the system is reliable, efficient, and suitable. And to further improve the performance of this project, here we are incorporating several techniques. So first, we have combined fusion model, with DQ and TD3 voting classifier, which combines random forest and decision tree in voting classifier to further improve the performance. So this combination improves the system's ability to make accurate and reliable predictions by taking advantage of both reinforcement learning and also the traditional machine learning models. And here, to make the system user friendly, here we have developed a simple web interface which is created using Flask framework, which allows users to input the data and get predictions directly from the system. This makes the system more interactive and user friendly, allowing people to easily test and see the results of the trained models. Moving on to the implementation. To implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand them. First, we have imported all the necessary programming libraries that are Python libraries and tools which are imported to handle data processing, model training, and web development. Then comes data ingestion. So here the network intrusion dataset is loaded into Pandas data frame, which makes it easy to work with the data in a structured format. Then comes data pre-processing. So here, any missing values in the data set are handled by either removing them or filling them in. And categorical labels are converted into format that the models can understand. And numerical features are standardized so that all values are on same scale, which helps the model perform better. Then comes data visualization. So at this stage, the dataset is explored through visualizations to understand patterns, distributions, and relationship between different features. This step helps to identify trends and potential issues in the data. Then comes data splitting. So here at this stage, we split the data into training and testing sets. So the training set is used to train the model and testing set is used to evaluate how well the models perform on unseen data. And all the models that are deep reinforcement learning models will be implemented here along with the machine learning model and the fusion models. So here we train on the prepared data set. Then comes model evaluation. So here at this stage, we will be evaluating all the machine learning models that we have trained and the DRL models that we have trained using accuracy, precision, recall, and FN score. And confusion matrix is used to identify false positives, which are normal activity flagged as attacks, and false negatives, which are attacks not detected. And we will be saving the best performing model for the future use. Coming to the front end, a user-friendly interface has been created using Flask framework where users can input network data features and the saved model is loaded. Input data is pre-processed, predictions are generated, and the results are displayed to the user. So this is how we have implemented. Now moving on to the algorithms used. These are the deep reinforcement learning algorithms which have been used in this project, which are DQN, DDPG, PPO, TD3, SAC. And coming to machine learning models, these are the machine learning models have been used. And in fusion models, that is the fusion model one, that is the proposed model here, we have combined two DRL models and one machine learning model. And in Fusion Model 2, we have combined DQ and TD3 and voting classifier, which combines random forest and decision trees. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the requirements that are needed for this project. And this is the overview of the project. Let's execute it. To execute, open the code folder that contains source code files. So let's open the code folder. So these are the source code files. Let's understand each of them. How will they be used in this project? So this is the model folder in which we have algorithm information and they will be loaded into the project code during runtime of the application. And here we have NSL KDD network intrusion detection dataset. So here we have data in these files and we will be extracting data from those files. And this is the static folder, which consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end. And here we have the extracted data set after loading from this folder. So let's see it, how it is. Let's open it. It's opening, just wait for a while. And here it is open. So here we have different attributes based on which we will be predicting whether there is intrusion detection or not, that is intrusion or not. So here are the different attributes. So up to X, we have the attributes, and this last variable, that is last column, is the target column that we will be predicting. So we will be training all the models on this data. Now close it. And this data set is extracted from this folder. And here we have multiple Jupyter notebook files. So these files, they contain combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. And here we have the process data set. So we have processed this above data set and we have stored it in this process data file. So let's wait, it's opening. So this is the pre-processed data set. After pre-processing, the data is stored in this format. Now let's close this. So this was the data, that is the raw data. Actually, this was the raw data. From that, we have extracted and saved it into XLS format. And this data set has been processed and saved as process data. And this is the database file, which is used to store the user information. So this is all about the code folder. Now let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path, click on enter. So this command is used to change the current directory to the code folder's path. So here you can see path has been changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So here, this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. So let's open that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get started first. Click on get started. And here you need to create an account for doing prediction and fill in all these details. I have already created account, so I will directly sign in. Click on sign in here. And you need to provide your credentials, which are username and the password. So I'm giving my username and the password. Now click on sign in. So we have entered invalid details. So let's enter them again. Now we have signed in successfully and redirected to this prediction page, prediction homepage. So now here we will be doing two kinds. One is directly we will be giving features as one case, and the other case we will be directly uploading the test case file to get the outputs. So first let's try using entering the features. So click on enter features. So here you can see we have n number of parameters which are need to be entered for doing prediction. So these are the parameters which are need to be entered for doing the prediction. So let's understand each of them. So first one we have is the duration. So this is how long the connection is lasted. And here we have protocol type. It is a type of protocol used, that is TCP, UDP or ICMP. And here we have service. Service is the network access during the connection. And here we have flag. Flag, it is the status of the connection. We have source bytes. Source bytes are the number of bytes sent from source to the destination. And then we have destination bytes. These are the number of bytes sent from destination back to the source. Then we have land. It indicates if the connection is from to the same host and the port. That is, if the connection is from the same host or the port. Then we have wrong fragment. It is the number of incorrect fragments in the packet. Then we have urgent. Urgent is the number of urgent packets sent. And coming to hot, hot is the number of hot indicators, that is suspicious activity like password guessing. And here we have failed logins. It is the number of failed login attempts. Then we have logged in. It is whether the login was successful or not. Then here we have compromised. Compromised is whether the system was compromised or not. Here we have root shell. Root shell is whether root shell access was obtained or not. And here we have SU attempted. So here it is the number of super user access attempts. And here we have root count. It is the number of root access. And here we have file creations. It is number of files created during the connection. Then we have shells. Shells is the number of shell prompts spawned. And then we have access files. So here access files are the number of sensitive files accessed. Then we have outbound commands. It is the number of commands sent to the other host. And then we have host login. Host login is number of logins to this host. And we have guest login. So guest login is number of guests that has been logged in. And then we have count. Count is number of guest login. Sorry, count is number of connections to the same host in the time window. Then we have service count. It is the error specific to a service. Then we have error rate. Error rate is general connection errors during the session. And then we have service error rate. It is the error specific to a particular service. And then we have reply error rate. It is the error in server replies. And then we have service reply error rate. It is the reply errors for a specific service. And we have same service rate. It is the fraction of connections to the same service. Then we have different S, that is different service rate. It is the fraction of connections to the same service, that is fraction of connections to the different services. Then we have service different host rate. It is the fraction of connections to the same service on different host. And then we have destination host count. It is the number of connections to the same destination host. And here we have destination host service. It is the number of connections to the same service on the destination host. And here we have destination host, same SRV rate. It is the fraction of same service connections to the destination host. And here we have destination host, different service rate. It is the fraction of different service connections to the destination host. And then we have destination host, same source port rate. It is the fraction of connections from the same source port to the destination host. So here we have destination host, service different host rate. It is the fraction of a service connections that go to different hosts. And here we have destination host error rate. It is the overall errors when connecting to the destination host. And then we have destination host service error rate. It is the overall errors when connecting to the dimension that is destination host. And then we have destination host reply error rate. It is the reply errors from the destination to the host. And then we have destination host service reply error rate. It is the reply errors for a specific service from the destination host. So this is all about the parameters. Now let's enter them. So here manually we will be entering features only one time. That is, we will be showing only one case, and rest case we will be showing in the uploading files because there are so many parameters that are need to be entered. So instead of that, we have created option of uploading file where we will be giving same parameters as the input, but just as a file. So let's open the test cases. Let's open this file. So this file only we will be giving as input, that we will be uploading it as file. So let's start entering them. So first we have the duration, that is 0, and protocol type is 1, and service is 0.637. And then we have flag as 0.9, and then source bytes are 1.05, and then destination bytes are 0. So we have zeros up to is guest login. So let's enter zeros up to is guest login. So destination bytes are 0, land is 0, wrong fragment is 0, urgent is 0, hot is 0, and failed logins are 0, logged in is 0. And here we have compromise 0, root shell 0, SU attempt is 0. And then we have root count 0, file creation 0, shells 0, access file 0, outbound command 0, host login 0, and guest login 0. Then we have count, that is 0.025. So let's enter it. And then we have SRV count, that is 0.001. Let's enter it. And error rate, that is, no, we have, yeah, correct only. And here we have error rate, that is 0. And then reply error rate. So we have 0, 4 zeros. So let's enter them. Service reply error rate is also 0. Then we have same service rate, that is 0.08. And then we have different SRV rate, that is 0.15, and service different host rate, that is 0. Destination host rate is 1. And then we have destination host service count. Then we have destination host, same SRV rate, that is 0, 0.6, 0.88, 0. We have again zeros up to last. So let's enter all values as zeros. So let's enter them. Now click on predict intrusion. So click on it. So here we got the detection result. So the detection is, it is detecting U2R attack has been detected with the confidence of 98.0222 confidence score. And the risk level is critical. And here we have attack type details where the attack type is user to root attack, that is U2R. And here is the description about the attack and common methods with this attack happens. So here we have potential security risk where critical privilege escalation, attempt to gain root or administrator access, complete system compromise risk, data integrity at risk, and system control may be lost. Similarly, we have possible root causes, we have recommended actions, we have technical analysis, we also have immediate next steps which are to be followed. So this is how you need to do prediction by entering the features. So similar way, you can enter n number of features and then n number of test cases. Then you will be getting the prediction whether attack has been detected or not. If the attack is detected, it will detect which type of attack it is, and it will also detect the risk level. Now let's try uploading the file. So click on upload file. And let's click on choose file. So before uploading file, you need to ensure that the file is in the format of CSV and ensure that there are 41 features in the file and we have, file should be of 10 MB. And these are the features that are expected when we upload the file. So let's upload file, click on choose file, select the same file that we have uploaded recently, click on open, and now click on analyze with DeepQ network. So click on it. So this given file, it will be pre-processed at the backend. It will be fed to the train model and the train model will be giving us a prediction. So here we have network analysis, that is network traffic analysis results. So here we have all the features that we have given as input. So here we have total so many test cases that we have given. For each test case, we have predicted class, and these are all the variables that we have given as input. Based on the given variables of each case, we have prediction result. So here you can see we have U2R result, we have normal result, we have U2R, and here we have for this case. So for this fifth case, we have normal result, and for seventh case, we have normal result, and for this 11th case, we have U2R prediction, and here for this case, we have prob prediction. Accordingly, for all the test cases, we have all the predictions. And even you can download this file also. So click on this download result file. Here, if you observe, we have the results downloaded. So this is the result file, and here we have predicted class. Now let's view the graphs. So click on analytics, and here we have the graphs. So first we have graph of sample outcome, which shows the class distribution of each class that we are predicting. So here on x-axis we have the values, the classes, and on y-axis we have count of each class. Now close it. And here if you click on information, that is icon, you will be able to see what is that graph about. So here we have accuracy score, comparison graph, where on x-axis we have all the models trained and on y-axis we have accuracy. And here you can see the description of what is accuracy score and for this project. And here we have precision score. So this is precision score comparison graph. And here we have information about it. Similarly, we have recall score. So this is recall score. And here we have FN score. So this is the FN score. And here we have radar graph. So this is the radar graph. Now close it. Click on sign out. So this project shows how combining smart algorithms and interactive tools can make network system much faster. And it not only improves the detection of cyber threats, but also makes it easier for users to understand and interact with the system, helping to protect data and networks more effectively in today's digital world. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.